Have you ever really thought about what happens when you're online? Every single time you send an email, watch a video, click on a link, you're sending information on this unbelievable high-speed journey across the entire globe. Well, today, we are pulling back the curtain on that secret journey to see exactly how it all works.
I mean, it feels like nothing, right? It's just instant. You click, a web page just appears. But what is really going on in that tiny split second between your click and that page loading? How does your computer, right there, ask a server, maybe thousands of miles away, for exactly the right thing and actually get it back?
Well, the answer isn't magic, even though it feels like it. It's actually a really elegant and standardized process. You can think of it like a universal language, a rule book that lets any two computers, no matter where they are in the world, have a perfect conversation. And today, we're going to take a peek inside that rule book. That rule book, that framework, is called the OSI model. And what it does is it breaks down the huge, complex job of network communication into 7 smaller, more manageable layers. Each layer has one specific job to do, and they all work together, one after the other, in perfect harmony.
Now, a quick heads up. The internet that we actually use today, it technically runs on a slightly different, more compact model. But if you really want to understand the theory and the concepts behind it all, the 7-layer OSI model is the absolute best way to learn. It just breaks things down into clearer steps, so that's what we're going to use as our guide.
So to really get this, we're not just going to talk about it, we're going to do it. We're going to follow one tiny piece of data on its journey. We'll start right inside your web browser, travel down all 7 of these layers as it gets ready to leave your computer, and then we'll see what happens the moment it arrives at its destination. But before we start, you gotta remember the names of these 7 layers, and there's a super handy, kind of silly trick for that. From the top layer down to the bottom, it goes application, presentation, session, transport, network, data link, and physical. Just remember this sentence: anxious, pale, Shakespeare, treated, nervous, drunks, patiently. Okay, so this is the roadmap for our data's outbound trip. It starts at the very top, at layer 7, and it works its way all the way down the stack. Now, this whole downward process has a special name: encapsulation. The best way to think of it is like putting a letter into an envelope, then putting that envelope into a slightly bigger one, and then that one into another, and so on. All right, let's kick this journey off. We're starting at the very top, layer 7. This is the layer that's closest to you. Now, it's not the app itself, it's not Chrome or your email program, but it's the part of that program that knows how to talk to the network. So when you type in a website and hit enter, this layer grabs that request and officially kicks off this whole communication chain. From there, your data hits layer 6, the presentation layer. This is basically the internet's universal translator. It takes the data from your specific app and converts it into a standard format that any other computer will be able to understand. It also does other really important jobs, like encryption, scrambling the data for security, and compression, which makes it smaller so it can travel faster. Okay, next up, layer 5, the connection manager. Its job is to open up the communication channel and keep it open for as long as it's needed. But what's really cool is that it creates a unique session for every single task. This is literally the reason you can have 10 different browser tabs open to 10 different websites, and the data for each one never ever gets mixed up. Each tab has its own protected session. Now we arrive at layer 4, the transport layer, and here, a really big decision has to be made. Does this communication need to be perfectly reliable, or does it need to be super fast? If you're loading a web page, it's going to choose TCP. TCP is meticulous. It double-checks that every single piece of data arrives, and in the right order. But if you're, say, on a video call, it might choose UDP. UDP is all about speed. It just blasts the data out as fast as it can. That's why your video might get a little blocky for a second if your connection is bad. Welcome to layer 3, which is basically the internet's GPS. The network layer is where the logical addresses get stamped on, the source and destination IP addresses. It's just like putting the to and from addresses on a letter. And then it looks at a giant map of the internet and figures out the absolute best, most efficient route for your data to take to get to its destination. So if layer 3 is the global GPS for the whole trip, you can think of layer 2, the data link layer, as the local mail carrier who just knows your neighborhood. It adds the physical hardware address, the MAC address, for the very next stop on the journey, which is probably your home router. It's all about making sure the data gets to its immediate next-door neighbor correctly. And we've made it to the bottom. At layer 1, all of that perfectly packaged, addressed, and translated data is finally turned into actual physical signals. We're talking electrical pulses zipping through a cable, tiny flashes of light in a fiber optic line, or radio waves floating through the air. Our digital message is now a real physical thing racing across the network. And there you have it. That entire journey that we just followed down the stack, that's called encapsulation. We literally just watched as each layer wrapped our data in a new header, a new set of instructions before passing it down to the next one. As the data gets all these new wrappers, its official name actually changes at each step. So in the top 3 layers, it's just called data. At layer 4, it's a segment. At layer 3, it becomes a packet. Layer 2 calls it a frame, and finally, when it's actually on the wire, it's just bits. Phew! Okay, our bits made it. They've crossed the network and they've just arrived at the destination server. So now what? Well, the server has to unwrap this big package to figure out what the original message was. And to do that, the entire process we just watched happens in reverse. This reverse journey is called de-encapsulation. The server just gets to work, having a rapid-fire unwrapping party. The physical layer turns the signals back into bits. The data link layer reads its header, then strips it off. The network layer checks the IP address, strips its header off, and so on, all the way back up the chain until the original, clean data is handed off to the right program on the server. Okay, I know. That was a lot of steps. 7 layers, encapsulation, de-encapsulation, all these different names. It seems incredibly complicated. So the really big question is, why? Why go through all this trouble? Why does any of this matter? This right here is the whole point. Because every single network-enabled device in the world agrees to follow this exact same set of rules, they can all talk to each other. It doesn't matter if you're on an iPhone and the server is a Linux machine built by a totally different company. This shared standard, this universal language, is the bedrock. It's the only thing that makes our global internet possible. All of that complexity, every single one of those layers and rules, it all comes down to one simple, ridiculously powerful idea. One model. One agreed-upon process for sending and receiving data. And that single agreement is what allows a planet's worth of completely different devices to connect and share information like it's nothing. Without it, there is no internet as we know it, period. And that kind of leaves you with a fascinating thought, doesn't it? This universal rulebook for data literally built our modern digital world. So it makes you wonder, what's the next universal language we're going to build? What's the next standard that will connect us all in ways we can't even imagine yet?